Hello. Today we're going to do 4.4, part of it at least, convert linear equations from standard form. So let's put the date, Monday, May 11th. Hopefully you had a nice weekend and that yesterday on Mother's Day you spent some time with your mom. What is standard form? Standard form is the name of an equation that has one side equal to 0 and the coefficient of x is always positive and never a decimal. It is never a fraction as well. So for example, 3x minus y plus 4 equals 0 and x plus 5y minus 7 equals 0. Notice that one side is equal to 0, so to the left of the equal sign versus to the right. Notice that to the right of the equal sign, it's equal to 0. To the left of the equal sign, to the right, notice that to the right of the equal sign, it's equal to 0. It's very usual to have the right side equal to 0. It's very typical. The coefficient of x is always positive and never a decimal. It's never a fraction. The number in front of x is the coefficient. So coefficient of x is the number in front of x, okay? Is positive, never a decimal, never a fraction. So 3, it's positive, it's not a decimal, and it's not a fraction. So it's in standard form. The x here has a 1, we understand to be there. 1 is the coefficient of x. It's positive, that's correct. It's not a decimal, that's correct. And it's never a fraction, that's also correct. So both of these are in standard form. What is slope y-intercept form? Slope y-intercept form is the name of an equation that can be written as y equals mx plus b. Notice that y is to the left of the equal sign, mx plus b is to the right. Notice that the 1 in front of y makes it in y equals mx plus b. Example 1. Using the guess method, state the slope and y-intercept for each linear relation that is graphed below, then write the equation for the relation in slope y-intercept form. So let's do guess. What's been given? Well, we've been given a graph of a linear relation. Graph of a linear relation, which we just know is a line. Okay, that's the fancy word for line, linear relation. We've also been given this equation. Notice that to the left of the equal sign, you've got numbers and variables. To the right of the equal sign, you have 0. Notice that the coefficient or number in front of x is not a negative, it's not a decimal, it's not a fraction. So this is the standard form for the line above. We could call it the linear relation. Okay? But we're wanting to focus on the slope, the y-intercept, and write the slope y-intercept form. So we've also been given the standard form So we're not going to do much about the standard form right now. We're going to focus on stating the slope and y-intercept, which is the unknown. So state the slope, okay, which we know is the m, okay. We want to state the y-intercept, which we know is the b, okay, and we want to write the equation in slope y-intercept form and then state the equation in slope y-intercept form. Okay, so the equation is y equals mx plus b. So we said the slope y-intercept form up here is y equals mx plus b. So S, the solution, I'm going to take what's been given, the unknown, and the equation. We're going to use y equals mx plus b, and we're going to use the graph. So how are we going to use the graph and the unknown to put the equation together? Well, we need the slope. So we need to sub in the slope. Remember that the slope is based on points of a line that go right through the corner of a grid square. So what I mean is these squares here, they've got corners, right? So the line has to go through a corner. Now, right now, this equation and this graph gives you two really large, very solid dots. They show up blue on my picture, okay? So the reason that they've been identified is because picking something that's not here could make us have a mistake. In other words, see how this red line is below the corner of a grid square. This red line is not at the corner. See, this is a corner, right? So the line doesn't go through a corner. This here does go through a corner. This is not at the corner, not exactly at the corner. So what we're saying is pick points that go through the corner of a grid square, okay? So if I pick these two and I go from left to right, remember my finger on my left travels so that it's underneath the finger on my right. I stop when I'm directly below the point on my right, and then I travel up, okay? So it has to make a 90-degree angle, and then I count my run. Remember that? So 1 space, 2 space, 3 space, 4 spaces. So 4 spaces is my run. So my run is 4, and my rise, 1, 2, 3, is my rise. So then I put that together. I know that my slope is rise over run, okay? And my rise is 3, and my run is 4. But I also know that my slope is m, okay? So I can put that value over here. I'm going to sub the slope of 3 over 4. Now, I not only need the m, but I need the b. So my b, where can I put that? My b is my y-intercept, okay? So my y-intercept is where the graph crosses the y-axis. Okay, so I know also that my y-intercept is b. So where does the graph cross the y-axis? So this is my y-axis here. So where does my red line cross the blue y-axis? Well, it's at -5. So that's my y-intercept is equal to -5. So my y-intercept is -5. That's where the graph crosses the y-axis. So I could also say that b, we know that the y-intercept is b, so it's -5. Okay? So I know that the y-intercept is b. So I'm going to sub the b value of -5 into my equation. So I get y equals m, which is 3 over 4, x, plus b, which is the same as -5. Okay, so my solution Therefore, the slope, which is m, is 3 over 4. My y-intercept, which is b, is negative 5. And y equals 3 over 4x minus 5 is the equation in slope y-intercept form. We know that slope y-intercept form contains the slope, which is m, and the y-intercept, which is negative 5 or b. Okay, so we've done that one. All right, let's go on. Using the guess method, state the slope and y-intercept for each linear relation that is graphed below, then write the equation for the relation in slope y-intercept form. So that instruction is for B as well. What have we been given? We've been given the graph of a linear relation, might want to turn the light on here. We know that that's the same as calling it a line, okay? And we've been given this equation. So notice that the left side has numbers and variables, and the right side is equal to 0. So that makes the slope y-intercept form. Or sorry, standard form. My apologies. So this is the standard form. Sorry about that. We have a cat and it was getting in the way. Right, so this is slope, standard form. So to the left of the equal sign is the numbers and the letters, okay? To the right is the equal sign with the 0. Okay, so this is the standard form for the linear relation above. All right, so we were also given x, I'll fix that, that should be a lowercase x, plus 2y minus 4 equals 0, okay? Which is the standard form. We're not going to talk much about how this standard form looks different from the slope y-intercept form, but we will eventually, okay? Now we haven't been given any values on our axes, so let's label that. So this is 0, so this would be 1, 2, 3, 4, 5. This is 0. To the left would be negative, negative 1. Notice I'm marking the lines there. It's the lines that are what we're counting, okay? That's negative 5. And to 0 going up is positive, so this line is 1, this line is 2, this line is 3, this line is 4, and this line is 5, right here. Okay. And then from 0 going down is negative, negative 1, negative 2, negative 3 right here, negative 4 that line, and negative 5 that line. All right, so you state the slope, which we know is m. state y-intercept, which we know is b, okay, and we want to state the equation in slope y-intercept form. U is the equation, okay, or sorry, E is the equation. The equation in slope y-intercept form is y equals mx plus b, okay? The S, the solution. Okay, so we're going to take the information from E, the information from U, and the information from the G, the given. So we're going to use y equals mx plus b. Okay, I'm going to use that. Now we have to sub in the m value for the slope and the b value for the y-intercept. So we have to sub in the m value. Well, we don't know what it is until we go back over to the graph and we pick 2 points going through corners of the grid squares. Okay. Now if I want, that looks like it's going through a corner of a grid square. Okay, so that could be a point that I use. Okay, this line, this is not going through the corner of a grid square because this corner's down here. I could use this one. Okay, I would not use this one. This is not at the corner of a grid square because remember, I'm trying to count my grid squares. Well, I can't count part of a grid square because it's too difficult to guess that correctly. This is another corner of a grid square. So I can pick any 2 points that I've identified here. Okay? I don't have to pick the ones that are here. I could pick this one and this one, but because I don't want my right triangle, which is what this is called, I don't want it to be larger than necessary. So I pick something that's small, right? So I would pick this one, okay, from here to here. Now, when I do that, I'm going from my left to my right as though I were reading, because that's basically what I'm doing. And I notice that to go from my left point to my right point, I'm dropping. So when I drop, I have to make that a negative. And remember, when I find my slope, picking 2 points on the corner of a grid square is required, and then counting how far down I drop is part of the slope. And then remember, I turn 90 degrees, okay, and then I run. I'm always running to the right because that's the way we read. I'm running the same amount as the number of grid squares. So 1, 2 is the amount I'm running. So in total, I'm taking all of this and I'm putting it into slope equals drop over run. Okay, so up above it was rise. Up above it was the rise, okay? But that was because it was rising going up. Here it's a drop because I'm going down to the right, down and then to the right. Okay, so my slope, which is drop over run, becomes a drop of -1 over a run of 2. Okay, but I also know that slope is the same as m. Okay, so that's my slope. I could put that value over here, -1 over 2, because I'm subbing it into the equation here. Now, not only do I need my slope, which I have found as m, I need my b, which is my y-intercept. Okay, so my y-intercept is equal to where the graph crosses the y-axis. Okay, the y-axis. It's also, the y-intercept is also b. Okay, so if I want to find my y-intercept where the graph crosses the y-axis and I want to call it b, I have to go to my graph. I'm gonna circle that too. Okay, there's my y. Okay, so this is my y-axis. So where does my line cross the y-axis? Okay, well that's right here. Right, my line crosses my blue y-axis at 2, the number 2. So 2 is my y-intercept. Okay, right there. All right, so B, which is my y-intercept where the graph crosses the y-axis, is 2. I can sub that over here. And then I sub it in. So y equals m, which is negative 1/2. So the m comes out and negative 1/2 replaces it. X, and then this is plus b, and this is positive 2. So I've done that part. So my solution, therefore the slope, which we were asked for, which is m, is negative 1/2. The y-intercept, which is b, is 2, and the equation y equals negative 1/2x plus 2 is the equation in slope y-intercept form. Is the equation. Okay, so remember, you're going to do these questions here. Okay, so when you're picking points to create your slope, you want to pick some, oh, they do. Look at how see how they're a little bit more obvious? So those are the ones they're asking you to use. Okay, see how they're obvious? Those are the ones you're asked to use. Oh, we could use 1, 2, these two. Actually, I would do left first. You could do these two, or if you wanted a really large right triangle, you could use these two. I wouldn't suggest it though, because then that means that you have to reduce your fraction. Okay, use these two. Use these two, or you could use these two. Okay. All right.